2015 cyclone season was particularly brutal in the Pacific. The main culprit is the return of El Niño, a weather phenomenon that appears on average every 3 to 7 years. El Niño is carefully monitored by long-term forecasters like Jacqueline, who works on the 3-month forecast of Météo France.
Il s'agit d'une anomalie de la température de surface de
This
l'océan.
is an anomaly that concerns the temperature of the surface water in the Pacific Ocean. The dominant winds in the Pacific are the trade winds, which push the warm surface water to the west. And then you have the situation with El Niño, where we see that the red zones move to the middle and the east of the Pacific, with the highest temperatures around 26 to 30 degrees, much further to the east. And in the atmosphere, above this warm water, there are very violent storms, vertical movement is much stronger, and precipitation is much stronger.
Not all El Niño events are alike, and this year, a particularly strong effect has been announced.
On est parti pour avoir un El Niño fort.
We're heading for another strong El Niño, one of the strongest in the last 50 years. We don't know yet if it's going to be a record breaker, but it's definitely strong this year.
A classic El Niño won't raise the temperature more than 1.5 degrees. The 97-98 El Niño rose to 2.3 or 2.5 degrees, depending on the area. Today, we are at 2 degrees, and we haven't yet reached the maximum.
The result is an exceptional cyclone season in the Pacific. Whether hurricanes, cyclones, or typhoons, the names change depending on where they take place. These spiraling storms have beaten several records in 2015.
In tropical storms, as soon as the wind speed is higher than 120 kilometers an hour, 74 miles an hour, they are categorized as cyclones. Below that is a tropical storm, and below that is a tropical depression. So in general, we take the forecast into account once it goes above tropical depression. We start to be very vigilant, and when it reaches tropical storm speed at 60 kilometers an hour, 37 miles an hour, we give it a name which allows us to follow it more easily.
El Niño is characterized by an abnormal rise in the temperature of the surface of the water in the East Pacific Ocean, a vital factor in the formation of one of the most sensational events of 2015, Hurricane Patricia. In October, the effects of El Niño began to make themselves felt. According to Eric Gilliardi, climatologist and specialist of the Pacific Ocean, the water was warmer than is normal at this time of the year by 2 degrees Celsius.
This is a zone where there are some cyclones, but not very strong, and they certainly don't develop to the same size as Patricia. Patricia is directly linked to the fact that we have an El Niño at the moment. The fact that the water is warm in the east and stays warm is a source of energy for the hurricane, allowing it to develop. The source, the seeds of a hurricane, are always there, but the fact that it develops into a real hurricane of the size of Patricia is linked to atmospheric and oceanic conditions that are conducive to development.
With these unusual conditions, a remarkable phenomenon occurs. Hurricane Patricia rapidly intensifies. In only 24 hours, it morphs from a tropical storm to a Category 5 hurricane.
Theoretically, any hurricane could grow to maximum strength, like Hurricane Patricia. But in general, with hurricanes, there are other factors which will limit its amplification. The water gets a bit colder, it reaches a landmass, or there are high-altitude winds that destabilize the hurricane. When we look at the particular conditions of this hurricane, it really grew. There was nothing to prevent it from building to its theoretical maximum intensity.
On October 23rd, Hurricane Patricia slammed into Central America, breaking the wind speed record for the North Pacific with an incredible 265 kilometers per hour. The violence of the storm caused multiple casualties. 12 people died in landslides caused by torrential rain or by falling trees. Luckily, the hurricane's path missed the largest cities on the Mexican coast. The authorities had safety measures in place prepared to house 260,000 people, but ultimately only 50,000 were evacuated. Hurricane Patricia headed inland towards the mountains, rapidly losing power. The total cost of the damages was estimated at $5 billion. The economic evaluation of natural disasters varies depending upon the countries in which they take place.
The problem with looking at it worldwide is that the most expensive catastrophes happen in the richest countries. So, worldwide, the U.S., because of the wealth in the U.S., if you have a hurricane, the same size hurricane in the U.S. will cause far more cost than a storm, the same storm in China, for example. So simply because there's much more of value, there's much more wealth in the path of the storm.
Koppu is a good example of the math involved in natural disasters. When it hit the Philippines, it became the deadliest typhoon of 2015. Winds up to 210 kilometers per hour were recorded. Vast plains of rice fields were submerged by flooding due to rain and gigantic waves. 47 people died in the Philippines, 4 times more than in Mexico during Hurricane Patricia. Yet the cost of the damage in this developing country was 20 times lower than in North America, only $231 million. To understand the intensity of this typhoon, we need to look once again at El Niño, even though this anomaly concerns the East Pacific rather than the West.
The warm water moves to the east, but the water in the west stays warm. So this water is going to stay warm enough that hurricanes can develop. In fact, it's more like the area is extended during an El Niño rather than the area moving. The zone in which hurricanes can develop spreads out, so there are more hurricanes.
El Niño is a phenomenon that matured in the second half of 2015. So it cannot be held responsible for the entire year's weather-related natural disasters. What would happen if global warming combined with a strong El Niño? Would the effects of the two phenomena multiply? So far, scientists are unable to tell, but numerous studies are underway.
Global warming amplifies, not just for El Niño, but for everything, the whole planet. It amplifies existing natural phenomena. This is a combination of global warming and El Niño. We have seen that El Niño affects a quarter of the surface of our planet. So when El Niño warms by 1 degree, the global temperature rises by 0.1 degrees.